In this lesson, we will learn about graphing systems of inequalities. Okay, so let's go ahead and review how to graph in slope-intercept form and also in standard form. Okay, so here we see in standard form. Okay, so what I'm going to do is I'm going to go ahead and graph the first one. Okay, so in the first equation here, if I set x equal to 0, then I can solve for y. So that means that 3y is greater than 6, so y has to be 2. Okay, then I'm going to set y equal to 0, which would give me 2x is greater than 6, so x would be 3. Okay, so I just found the x-intercept and the y-intercept, and now I'm going to graph the point, or now I'm going to connect the points. So 0, 2, and 3, 0. Okay, and then the other one, oops, I'm sorry, this should be a dotted line because I just have greater than. Okay, and then to graph the second one, if I set x equal to 0, y would be negative 2y is less than 8. So y would be negative 4. Okay, and then if I set y equal to 0, x is going to be 2. So my next point here is 2, 0, and 0, negative 4. Okay, and then this gets a dotted line as well. Okay, so here we've just graphed the system. Okay, I'm not going to go ahead and show the inequalities just yet. So let's look at the second one. Okay, we already have it in slope-intercept form, so I'm going to go ahead and start to graph. Starting at negative 3, rise 2, run 1. Okay, this gets a filled in line because it's greater than or equal to. Then the next one is starting at the y-intercept of 4, down 3, to the right 1, and I'm going to graph this one as well. Okay? All right, so there's still one more step that we have to add with the inequalities, and that's the shading. So I'm going to show you that on the next page. Okay, so what I think would be the easiest to do is graph each one separately. Okay, so if I want to start off with the first one, y is less than or equal to 4. Okay, so I'm going to find y on here. So y is always 4. Okay, so y is 4 here, y is 4 here, y is always 4. Okay, if I want to show that it's less than or equal to 4, that means that all the space down here, all of these y values are less than or equal to 4. Okay, so now I'm going to graph the other one here, starting at negative 5, rise 2, run 1. Okay, here it gets a dotted line because it's just greater than. Okay, and now is where I have to find a point. Okay, so I'm going to choose the point here of 1, 1. Okay, remember that you want to choose a point that's either clearly on the left side or the right side of the line. Okay, you don't want to choose one that goes directly through it. So if I plug in 1 for x and y, I get that 1 is greater than negative 3. Okay, this is a true statement. 1 is greater than negative 3. So that means that all of this side gets shaded in. Okay, so notice that I graphed one line, shaded it, and then graphed the other line and shaded it. Now we see that where the lines intersect, okay, where I see red and blue is my solution. So everything right here that I'm shading in green, okay, this is all of the area that satisfies both inequalities. Okay, let's try the next one. Okay, so here I have that y is less than 2x minus 4. Okay, so go down to minus 4, rise 2, run 1. Okay, I get a dotted line here because it's less than. And now I'm going to choose the point of 1, 1. So I'm filling in 1 for x and y. So I get 1 is less than negative 2. Okay, this is not true. So I'm going to shade the opposite side. So all of the solutions over here must be true. Okay, moving on to the next one. So here I have y is greater than 2x plus 1. So starting at 1, rise 2, run 1. Okay, I get a dotted line here as well. I'm going to use this same point right here of 1, 1. So 1 is greater than 2 times 1 plus 1. So 1 is greater than 3. Okay, this is not true either, so I'm going to shade the opposite side. Okay, so these are not intersecting at all, so the solution set is over here in the blue and over here in the red. Okay, so please pause the video for a moment and try these on your own. Okay, so let's see how you did. So y is greater than x plus 2, so starting at 2. Rise 1, run 1, because the slope here is 1 over 1. Okay, we get a dotted line. Okay, I'm going to choose the point of 1, 1. So 1 is greater than 1 plus 2. 1, oops, this should be 2. 1 is greater than 3. That is not true, so I'm going to shade in the side, the opposite side. Okay, moving on to the next one. Y is greater than or equal to 2x plus 1. Okay, so, oops, sorry, let me erase that. Okay, this should be on the 1. Rise 2, run 1. Okay, this line is filled in because it's greater than or equal to. And I'll choose the same point here of 1, 1. So 1 is greater than or equal 2 times 1 plus 1. 1 is greater than or equal to 3. Okay, that is not true, so I'm going to shade the opposite side, which would be over here. Okay, so now we want to find the point where they overlap is the point of intersection. Okay, so everything that has both colors here would be right here. Okay, so my solution is everything in green. Okay, and then let's try the next one. Y is less than or equal to 3x minus 4. So starting at minus 4, rise 3, run 1. Okay, it's filled in because it's less than or equal to. Okay, choosing a point of 1, 1. 1 is less than or equal to 3 times 1 minus 4. 1 is less than or equal to negative 1. Is 1 less than negative 1? No, that's not true. So I'm going to shade in the opposite side. Okay, moving on to the next one. Here I have y is greater than or equal to negative 2x plus 1. So starting at the y-intercept, 1. My slope is negative 2, so down 2, to the right 1. Again, this gets filled in because it's greater than or equal to. I'm going to use the same point here of 1, 1. 1 is greater than or equal to negative 2 times 1 plus 1. So 1 is greater than or equal to, so negative 2 plus 1 is negative 1. Okay, this is a true statement. 1 is greater than or equal to negative 1, so everything on this side of the blue line gets shaded in. Okay, so then again here the point of intersection is where the red and the blue are. Okay, so everything right in here. Okay, and so that is solving for systems of inequalities. Okay, so just like we solved for one inequality before where we shaded in, we're just doing the same thing, but we're doing it twice and seeing where they overlap.